Respected Coordinator, Dr.Malik Asif Aziz, respected Resource Person, Dr. Chesti, dear participants, scholars, Assalamu Alaikum. I'm Zora Shabir, PhD Scholar Division of Plant Pathology, and I welcome you all in the second day of training program. Today's lecture will be delivered by Dr. Chesti, Division of Soil Science and Agricultural Chemistry. Sir is an associate professor in the same division. Sir has an experience of more than 60 years. He has more than 60 publications in international and national journals. Sir has guided more than 40 MSc and PhD students. Sir has an expertise in soil fertility, soil analysis, soil and water conservation, plant nutrition, fertilizers, nutrient management, soil chemistry, soil conservation, organic farming, soil biology, and many more. Sir will today deliver a lecture on low-cost vermicomposting technology. I please welcome our resource person on the stage with a big round of applause.
A very good morning to all of you and Assalamu Alaikum. Firstly, I will thank Dr. Asif for giving me an opportunity to deliver a lecture under this training program, 1 week advanced training program on vermicompost technology, a sustainable livelihood operation for rural farming and community of Kashmir. As we all know, in India, the total this residue, plant residue, crop residue, and this manure production generation is very high. It is nearly more than 500 million tons each, crop residue as well as animal residue. Out of this 500 million residue, crop residue, only nearly 140 million tons that remains unutilized, that is surplus. And out of those 142 million tons, 92 million tons is burned. If you will Google this time regarding Punjab, Haryana or Delhi, you will see it is just like they are burning. They are burning that crop residue. But if we see the scenario of soils, before Green Revolution we were getting 50 million tons of yield, but at present we are getting more than 330 million tons of these food grain yields. For those that we deplete, we mine nearly 36 million tons of nutrients every year. However, by all replenishments, we give only 27 to 28 million tons to the soil. With the result, there is a deficit of 8 to 10 million tons every year. That is why our soil is deteriorating and our fertilizer use efficiency is decreasing. Today, my topic is low-cost vermicomposting. Due to this poor management of crop residue, or we can say manure, which is produced, generated in our country, there are some cause which may cause, number one, which may cause water pollution. That is, eutrophication is there, enrichment of these nutrients in the soil. There is an air pollution when we burn these residues. When there is an air pollution, there is an increase in greenhouse gases, mostly carbon dioxide, methane. And the methane, the main source of methane is ruminant livestock and has highest contribution in greenhouse gases due to respiration and enteric fermentation. In addition to these environmental impacts, there is a huge loss of nutrients. If we will decompose it, we can get nearly 80 to 20 million tons of nutrients. And that deficit, which is 8 to 10, we can replenish it with these nutrients. And in addition to that, we may say that it may cause, if we will keep it unutilized, unattended in our farms or any other near the streams or rivers, it may cause health risks and environmental problems. Now, what are the options? If we can say, what will be the option for us? Number one option may be, we may collect it and dispose it somewhere. For example, in our Srinagar city, there is some disposing sites at near Idgah side. Okay? But it is very much costly. And the second option for us is to go for the composting. We can reuse it and we can go for composting. And what is composting? It is the conversion of organic wastes into nutrient-rich material. And before this vermicomposting, we were using different methods of composting. Do you know about indoor method of composting? Bangalore method of composting or Nordic method of composting? What is indoor? Indoor method of composting, it is an aerated method of composting, it was started by Howard. In that, we generally prepare a pit of nearly 3 feet depth, 5 feet width. Length is up to us, how much manure we have. It may be up to 9 feet or up to 15 feet. We will prepare that. In that pit, we just apply all the plant residues which are degradable. A layer of that, 5 to 6 inches. Then we add to it cow dung, 5 to 6 inch. The same alternate layers until and unless it gets filled up to 1 feet above the ground level. And during this, we add regularly water to it. In this case, when it is after 1 feet above the ground, we keep it as such. In 10 to 15 days, it comes down. We just plaster it. We just plaster it with mud with clay with water, and then we plaster it. There comes a fissures in it. After 15 days, we turn it. Then after 1 month, we again turn it. But during this process, we add water to it. And after 3 months, there is a third turning to it. That's indoor method. After 3 to 4 months, our compost is prepared. That was a traditional method. Second one was Bangalore method of composting, which were farmers using. Bangalore method. It was given by Acharya. So, उसमें क्या हुआ? उसमें क्या करता था? Same is the process. Width of that pit is 5 feet, depth is 3 feet, and length is up to 15 to 20 feet. It depends. It may be 10 feet, it may be 20 feet, or it may be 30 feet. It depends upon the material which is available with him. In that, he just added organic residues, a layer of organic residues, then a layer of this cow dung, 3 to 6 inch this organic waste, 3 to 6 inch manure, then alternate. Okay? Then he filled it up to 2 feet above the ground. After some time, it comes down. Then he mud plastered it with clay, and there is no turning in that. And after some time, there may be a fissures or cracks. Then we will add some water through these fissures, and we will again cover it with mud. That is anaerobic method. That is Bangalore method. In that method, it may took nearly 6 months, 5 to 6 months for composting. And there is a difference in composting. In indoor method, due to this turning, the compost is better than Bangalore method. Then comes the vermicomposting. Now, what is vermicomposting? Vermicomposting is just worms, they eat that organic material, and that excreta hai, that's called vermicompost. And one thing should be kept in your mind, that when we add fertilizers, we add water-soluble fertilizers to the plant. But when we add compost to the soil, we feed the soil. When we will feed the soil, the physico-chemical properties of the soil will improve, and with the result, the plant growth will improve. Vermitechnology, we may not call it vermicompost, we may call it vermitechnology. It is just like a natural bioreactor. And it has 3 parts. One is vermicomposting, then other is vermiwash production, and third one is vermiculture or vermi. Darwin, he has called these earthworms as unhurled soldiers of the mankind. Before this invention of plows, tractors, who was plowing the soil? It was these plow. The plow is one of the most ancient and most valuable of man's inventions, but long before it existed, the land was regularly plowed and still continues to be plowed by earthworms. It may be doubtful whether these there are many other animals which have played so important part in the history of world as these slowly organized creatures. It was given by Darwin. Now, some of the anatomy and physiology of these earthworms. Mostly, these are macro animals present in the soil, and it has been observed that there are 27 to 4,200 species. Out of these, some of the species may be 20 mm, and some of the species are up to 1 meter. And recently, in some research papers, some of the earthworms' length may be up to 4 to 7 meters. They are egg-laying hermaphrodites. They have both male and female organs. They eat this dead material, organic matter, microorganisms found in these materials, and they do not eat living roots or plants. One of the advantage of this is, and they act as a pest, not act as pest crops. This is the anatomy. Through mouth, then pharynx is there, esophagus, crop, gizzard. This gizzard, वहाँ पे ये grind करता है इसको, जो भी ये खाता है gizzard में, it grinds it. Then through the anus, it is excreted. How these worms produce? Worms eat organic matter and pass it through the digestive system, producing castings or vermicompost. There are 3 types of earthworms. Normally, we can say 2,700 to 4,200 species. They have been categorized into 3. One is epigeic, second one is endogeic, and third one is anasic. What is epigeic? These are the surface eaters. These are the worms which eat this organic matter and convert it into vermicompost. Second, and they live on the surface nearly 0 to 20 centimeters. Second one is endogeic. They live below the soil, that means subsoil. A horizon and B horizon, just below A horizon. They live there and they eat the soil. And the third one is anic. They are the deep burrowers. They just cause the burrowing in the soil, in and out, vertical. Now, in the one earthworm that is important for us is epigeic. We can call it Aisina foetida. They live in high organic matter. They feed on decaying organic matter, leaves, shoots, dung, and they live on the surface of the 0 to 15 centimeters. Now, endogeic, they are shallow burrowing. They feed on the soil, and they live below the depth, 20 to 30 centimeters of the depth. Some of the species of it is grey worm, blue grey worm, or night crawlers. Subsoil dwellers, or we can say anic, they live below the subsoil. They are large, tend to live in permanent burrows, and just like rats, just like burrows, deep vertical burrows. That is why Darwin has called unhurt soldiers. They are doing their work, they are following the soil. And the example of that is Aporectida longa. Now, what kind of earthworms? For temperate regions, it is Aisina foetida. Then Eudrilus, Eugenia, and Pyronyx, they are mainly for high temperature, tropical areas or subtropical areas. And we have isolated some earthworms here. That is Aporectida, Aporectida rosea, and Apophobia species, which are locally here. But why we are using this red worm, Aisina foetida, or we can say it also red worm or European worm. What are its features? Some of the features of this worm. Worms do not have eyes but cells in their front part of their body to detect light. Worms do not have teeth but they grind food by using grit in their gizzard. Worms can eat half of their body weight. That is their advantage. Why we are not using local worms or other worms? Main advantage here is their multiplication rate, and they can eat half of their weight. And they have 5 heart-like organ aerotic arches. Worms have both male and female reproductive organs, but they always need one another for their reproduction. And Aisina foetida, in a mature worm. Firstly, it is a cocoon. In cocoon, there are hatchlings. Then after hatchlings, they mature up to 11 weeks. That is up to 2 months. They will become mature. Then they will itself go for multiplication. One mature worm can produce 100 worms in a year, live up to 1 year, through their skin. So it is important to keep their environment moist, and if it is too wet, they will die. In addition to that, they cannot work below 2 feet. They will die. If you hold worms on a long time on a hand, there will be a yellow secretion, that is coelomic fluid. That's foul smelling. And due to this foul smelling, we call it Foetida. Aisna Foetida. This is a life cycle of this, how the reproduction occurs, male and female. They have both male and female organs. They will reproduce, they will lay the cocoons. In each cocoon, there may be 3 or 4 these hatchlings. Under favorable conditions, red regular worm will multiply rapidly. Your question may be how one is converted into 100. That is the advantage of this isona multiplication rate. Second one, they eat the organic matter more than half of their weight. A mature red worm can produce 2 to 3 cocoons per week. That means if a population and productivity in 11 weeks, we may say 3 cocoons. In each cocoon, there are 3 hatchlings. 3 is 3 is 9. In 11 months, they will get converted into 99 hatchlings per worm. In 2 to 3 months, these hatchlings will mature. They will be mature breeders, producing offspring of their own. At the same time, their parents are continuing to mate and create offspring. Isona Foetida, main features, we call it red worm, we call it tiger worm, we call it manure worm. Different literature mein, they can eat half of their weight. About half kg contains 1,000 worms. Now, the materials which can be used for this vermicomposting material: crop and animal residue, vegetable wastes, hotel refuse. Hotel refuse में maximum we can say vegetables जो बचता है उसमें, weed biomass, litter, waste from agro industries, biodegradable portion of urban and rural wastes. What not to feed worms? Mainly even on Monday I have visited one vermicompost. I have a lecture there at Seed Farm Tapar. There is well-developed vermicompost unit, but that is different. Even when I joined SKUAST, Jammu, I have a project on improving the productivity of traditional agriculture at Rajori. We have prepared nearly 20 to 30 vermicompost units. Even the vermicompost units which were prepared by the government or any other agency there, they were not working. The reason was that they have prepared it, but there was not a proper training to that farmer or the stakeholder regarding how we can prepare this vermicompost. For example, he was not knowing which material I have to add. Sometimes he may have prepared it, he may have added some of these things, just like meat, greasy or oily foods, plastic or foil or other organics, bones, dairy products, cat or dog feces, materials, pungents. It is onion, chili, garlic, citrus, acid producing those. It is not advisable to use them for vermicomposting. Organic waste is containing high amount of ammonia. No doubt, to every organic manure we can add those worms to convert it into vermicompost. For example, if we will add this poultry manure, it is high content of nitrogen, 3 to 4%. This farmyard manure has only 0.5%. That means, and the nitrogen that's present in it is in the form of ammonia. It is not advisable to use freshly available this poultry manure. What may be the cause if we will add it to the vermicompost unit? a disease called sour soup or protein poisoning caused by the environmental cause due to much protein in the bedding and produces acids and gases as it decays, which results in the worm as a swallowing colectrum, जो gizzard के नीचे उसका part होता है. You will see the vermicompost unit. They will not be comfortable with sour this crop. उनका stomach जो होगा, that will be sore, and they will be just crawling on the surface. And some of the predators, in addition to this, no doubt we add that material. There are some predators which will eat them. Some of the targets may be birds, moles, rodents, protozoa, ants, and red mites. They may cause damage to these worms. Do worms have some enemies? Yes, birds, frogs, fish, ants, rodents. Now, what are the ideal conditions for production of this? Is the main science in this vermicompost. What are the ideal conditions? Whenever there is a manure somewhere, firstly there is a latent heat, mesophilic work. After some time, if we will put our hand in that manure, the temperature may go up to 60 degrees in that manure. When we go for the vermicomposting, we apply this. If there is a fresh manure, we will add it into the compost pit and we will put the worms there. Worms they need the temperature between 25 to 35 degrees. If the temperature is more than 40, more than 50, they will die. Number one is temperature. The temperature should be between 25 to 35 for isonaputida. And second one was the material which we use, cow dung, it should be partially decomposed. It should be nearly 35 to 45 days old. It depends. If it is autumn, we may have to keep it up to 60 days. If it is June, July or August, we can use up to 15 or 20 days old this cow dung for that. Third one is moisture. Whenever we prepare it, there should be a proper moisture. It should be between 60 to 70 degrees, 70%. That means 60 to 70, or we may go up to 80% of the moisture. And how we will check the moisture? We will take a handful of that compost. If our hands get wet, we can't use every time 60%, 70% moisture. No, we will take a handful, and if our hands get moist, that moisture is sufficient there. Fourth one is aeration. These are surface dwellers. They eat that matter because they remain between 0 to 30, 0 to 20 centimeters. They are surface dwellers. That means we should keep the depth or height of that material up to not more than 2 feet. Mostly the vermicompost units fail due to these conditions. First one, the temperature may be high because we are using fresh manure. Second one, the manure which we use, that may not be have been decomposed fully. That may be 10 or 12 days, or in some places they will directly put that manure, fresh manure, into the vermicompost unit. That's why the vermicompost units have been failed. And next one was due to aeration problem. No doubt, whenever there is a pit, it is 3 feet or 4 feet depth. They fill it 100%. Full. Worm will work only up to 2 feet, but not below that. They will not move down, and that may be the reason it may take. It may take 60 to 70 days. It may take 4 or 6 months because they will not work below that. And the pH of the material should be acidic. The pH should be ideal, it should be neutral, because it should not be. For that we should not use those materials which are acid forming. उसमें मैंने आपको कहा citrus है, lemon है, and this onion peels or any other greasy or oily material. Methods of vermicomposting. We are coming to the low cost now. This was just an introduction regarding the first method was heap method. That means we can prepare that vermicompost on the surface. Second one is we can prepare it in the pit, just like Bangalore method or indoor method. We can prepare it on the floor, or we can prepare it in the pit. Third one is low cost vermicompost. It is also a pit method. Fourth one is portable vermibed method. ये वहाँ से ही आता है मार्केट में पोर्टेबल, उसमें सिर्फ we have to put the material, farmyard manure and worms. And the fifth one is vermicompost prepared above the ground by using cement rings. We can prepare it in those areas, for example, as a kitchen garden. Pit or heap method. It is preferable to go optimum size. If we have to prepare a pit method for vermicompost, we have to prepare a pit. The depth of the pit should be 3 feet depth, and length, width should be also width should be 3 feet, depth should be 3 feet, and length is up to you, how much material you have. But if the depth is 3 feet, we have to put the material up to only 2 feet in that, in pit method. Second one is on the floor. We can prepare a dome shaped of manure. Firstly, we will add 5 to 6 inches of grass or biodegradable material on the floor or on the pit. Then we will add 5 to 6 inches of cow dung. But what type of cow dung we should use? That should be partially decomposed. 30 to 45 days. We will put a layer of residue, then a layer of cow dung, partially decomposed, up to the 2 feet. Then we will put the worms into it. That is in the form of on the ground. We can prepare it. Now vermicompost prepared under tree. This type of vermicompost I have prepared in Rajuri, because they have locally available stools there. They can use it. It is not needed. We can use thatch grass, not teen. We can use locally available थोड़ा बहुत जो भी मटेरियल हमारे पास लगती होगी, we can prepare that. ठीक है? इसमें क्या करना है? Underground open permanent pits, 10 feet length, 3 feet width and 2 feet depth. Pits were prepared under the tree. Why under the tree? Shade. Otherwise we have to water it frequently. ठीक है? We should be 1 feet above the ground. The pit, it should be above the ground 1 feet. Why? Otherwise the rainwater may go into it. The floor of the pit should be partially concrete with small stones and pieces. It should not be concrete. Sometimes the water may be more. When we apply water, it may be more there. And where will it go? It may, at the wet conditions, under wet conditions, they may die. Above ground walls are constructed above the pit. Then partially decomposed manure spread on the bottom. This was followed by the addition of layer of crop residues in the ratio of 1:1. This was followed, then a second layer of dung, then a layer of this manure. 2 species Isonophytida, 2 to 3 kgs per pit under temperate conditions. If it is UP, Jammu or any other condition, we can use pyroxene exudates there under tropical conditions. Then moisture content, we have to maintain 60 to 70% throughout the decomposition period. Jute bags, because it has some enemies, when it got frogs, ants, birds, we can apply those jute bags above it. They need aeration, they need moisture. We can't use polythene above it. Otherwise, the vermicompost will get failed. We use gummy bags, thatch grass, or we can use thatch grass, where spread on the surface of the material to facilitate maintenance suitable moisture regime and temperature. Watering by sprinkling. It is not itna water ho to usme lump formation ho jaye. And we have to check it after every 3 days or after every 7 days. It depends upon the climate. The materials were allowed to decompose after 60 to 75 days. Under winter conditions, it will took 100 days, it will took 110 days. It depends upon the climate conditions. This is the pit or heap method. We have already discussed it. Now, low-cost vermicompost production. SKUAST has developed a technology for this low-cost vermicompost technology. जो normal vermicompost है, that it paid nearly 60 to 70,000 rupees. We have to go for 60 to 70,000 rupees. But for this, we thought, because the farmer can use his own resources for that, which is available to him, it may cost not more than 5 to 10,000 rupees to him. First process is pit digging. Pit digging, we will go for 10 feet of length, 3 feet of depth, 3 feet or 2 feet of height, जो depth है उसमें, ठीक है? Now after that, evacuation of pits. After that, preparation of mud plastering. जो high cost vermicompost, we generally use bricks. However, in this case, we will plaster the walls with these mud plastering. After mud plastering of pits, we can use timber or cladding material. We do not need this tin or any other iron rods for that. Locally, we can, that is available with the farmer. This is ready to use pits for vermicompost. Only science in that, this is, the depth should be 3 feet, but we will apply the material up to 2 feet. Width should be 3 feet, and length, it depends upon the farmer, how much material how much material is available to him. Okay, we may go for 10 feet to 20 up to 30 feet length, but depth should not be more than 2 feet or 3 feet. This is the feeding material, animal waste, most vegetable and fruit wastes, agriculture wastes. We can chop it, municipal waste, kitchen waste. We can trash them, eggshells, or in agro-industry wastes, things not to use, which we have already discussed, oily or greasy foods, or dog or cat fishes, or poultry manure, fresh poultry manure. This is how we can chop this material to increase. इसमें कम time हमें फिर लगेगा if we will do these processes. Then we can, what should be the concentration? What should be the concentration of this when we prepare this vermicompost? Cow dung, poultry manure, rice straw, or legume waste, it should be 70, 50, 15, 7.5 and 7.5 ratio. But normally we do not have available this poultry manure. We can go for cow dung and kitchen waste 80-20, or if it is not available, we can go for a residue 1:1, 1%, 50% residue, 50% manure. That is, there are various options. It depends. This is pit filling. Fill the pit with the half decomposed feeding material, earthworms, 10 quintals, or it should be up to 2 feet. Then after pit filling, addition of earthworms, isophytida 2.5 to 3 kg worms we can add. Covering and watering. For that we can plaster, after mud plastering we can use this polythene on the sides, but not above. We have to use dummy bags to have well aerated conditions and maintenance of the temperature. Frequently, if it is July, August, September, we have to go for, after every 3 days we have to check the moisture. During these days we can go check the moisture after 1 week or 2 weeks. Turning of the compost to increase its this turning of the compost. Then we can go for this sieving of the compost. This is the vermicompost, low cost vermicompost unit. Vermicompost unit under TSP Grace, locally available. They have students are available with them. They can use one bag of cement and they can prepare this. There's no need of steam. We can also use grass, thatch grass. because it needs some moisture. अगर उसमें कोई पानी जाएगा भी तो we can use that. Portable vermi bed, this is another method. वो वहाँ से ही आता है portable bed. It is 12 feet, 4 feet and 2 feet length, breadth and depth. And we will prepare the vermicompost same, in which we have prepared in pit method or heap method. Procedure is same. This is a type of vermi bed. अगर किसी के पास जगह नहीं होगी, लेबर नहीं है, he can use it for 3 to 4 months. Then he will wrap it. साइड में रखेगा तो मटेरियल उसके पास अवेलेबल होगा, he can use it. Sometimes in cities they do not have manure, they do not have other even area to prepare a vermicompost. For that they can prepare this vermicompost in cemented rings. For that, this is a process. The waste material is spread on the polythene sheet. Waste material में maximum उसके पास होता है kitchen waste. Make a heap up to 1 meter height in the layers. Paste a top of heap of soil and a cow dung there. Allow material to decompose for 30 to 40 days to pass through this thermophilic stage. We can't use those worms at that moment. Release worms through the cracks when the temperature comes down. Cover the heap with straw, gummy bags to prevent moisture loss. Sprinkle water every third day to maintain adequate quantity. For this cemented rings, firstly we will take a material plaster sheet in below rings. जो rings होंगे, we will use 3 rings up to height of 3 feet and its width will be 3 feet. Then layer of raw material is placed on the polythene sheet above this. Then we can use sometimes rock phosphate in that. That type of vermicompost will be phosphorus rich because rock phosphate it contains nearly 32% phosphorus, and it is tricalcium phosphate. It is unavailable to the plant. It is in the insoluble form. But when we add it with the organic manures, it will get converted into water soluble. For that rock phosphate, we can add this rock phosphate to some organic material to increase its availability. Rock phosphate powder is sprinkled on this organic material. Then we can use a slurry of cow dung. They will act as inoculants of microbes. And we will plaster that material in the ring and seal with the cow dung. Then earthworms are released nearer to the cracks. We can put gummy bags on it. This is the vermicompost that is processed and is produced in the cement rings. Easy method. Then harvesting of this worms. How we can harvest these worms? There's 3 methods. In the pit method or heap method, we can keep the fresh material on other side. We can take this on one side prepared. The worms will move from this prepared to that which is fresh. That's one method. In second method, we can keep it in under sun. We will make heaps. The worms will move down. We can harvest that vermicompost on the upper side. Third one is we can make these balls of these. Put some fresh cow dung balls into the vermicompost pit. They will attract it, and after 24 hours, the cow dung ball is removed. All the worms will be adhered to that ball because they have a meat. वहाँ पे इसको खाना होगा. He has utilized that material, that energy which is present in that compost pit. Then biofortification, we can add to vermicompost. We can add nitrogen fixers, fixers, rhizobium or trichoderma or VAM to increase its biofortification. Then vermiculture, how we can prepare vermiculture? One was vermicomposting, another one is vermiculture. Earthworms can be multiplied into 1:1 mixture of cow dung and decaying leaves kept in cement tank or wooden box with proper drainage should be there. The nucleus culture of worm needs to be introduced in the above mixture at the rate of 100 worms per 10 kg of organic waste, that properly mulched and dried with grass or straw or wet gummy bags. The unit should be kept in shade. No doubt, vermicompost second component is vermiculture. This is the chemical compost of vermicompost, but this composition will vary. If there is a kitchen waste, composition will be different. If we use poultry manure, the composition of nitrogen, phosphorus will change. If we will use farmyard manure, the composition will this cow dung, the composition will be different. This is an average for your information. Now, what is the rate of application? It is too costly. 1 kg may cost, sir, up to 15 to 20 rupees. That's why we have to use it cautiously. For field crops, generally we use 10 to 20 tons of farmyard manure. For that, we can use 5 to 6 tons vermicompost because it is nutrient rich than farmyard manure. Fruit crops, we can use 5 to 7 kg per plant. However, the recommendation is nearly we have to use more than 40 to 50 kg per plant.
Depending upon the age.
Depend upon the age. If the age of the plant is more than 15 years. And for pot crops, it is up to, or flower crops, it is 100 to 200 grams per pot. This is the method. Now, this is the economic benefit cost ratio of if we will go for the vermicompost unit. If on the small scale, we will use 52,000 rupees. The benefit, your total cost benefit ratio, it will be 1 to 1.73. For medium, if we will go for 1 lakh, it is 1 is to 1.85. For large scale, if it is 2 to 2.25 lakhs, it is 1 is to 2. That is on the larger scale if we will go for. If it is 2.25 lakhs, we may earn nearly 1 to half, 1 to 2%. Then vermiwash. What is vermiwash? It is just like we can say a column. We will make a column. In the column, we will use partially decomposed manure and we will add worms and we will trickle down the water through it. And the जो नीचे पानी आएगा, that's vermiwash. The trickling of water takes away all the body secretions of the worms along with the nutrients from the decomposed material. The collected water contains many nutrients readily available. What are the benefits of it? It acts as a plant tonic and we can add 1 liter with this cow urine and we can separate as a biopesticide or a nutrient with liquid manure. These are the requirements for this. We should have a bucket with tape, cow dung, but cow dung should be partially decomposed. It depends, 30 to 45 days old. Earthworms, this is the method. In a bucket, firstly we will take 1 big bucket or earthen pot, set up 1 stopcock on the lowermost pot of the bucket, then put a layer of broken bricks or stones having thickness of 10 to 15 centimeters below. Then over that, we will put another 10 to 15 centimeters sand. See? Then 40 to 45 centimeters partially decomposed manure. After that, we will put a worms, 1,000, 2,000. If we will put more, there will be more water will be in contact with it, there will be more secretion. That secretion will be rich of nutrients and plant growth, hormones. After that, a layer of paddy straw is put on that, 6 centimeters thickness is given. Hang out a pot with a bottom hole over the bucket in such a way so that water falls drop by drop. When it gets filled, that vermiwash is available to us. This is the photograph. Pot को हम होल रखेंगे, उसमें से pot trickle down होके नीचे जो नल से आएगा, that's vermiwash. Vermiwash unit has been established at large scale, but there should be some precautions during this vermiwash preparation. Water should be poured slowly, drop-wise. Do not mix undecomposed material. Do not add any green material. Do not allow, because at that moment we need only its secretion. It is not for decomposition at that point. Do not allow, compare the contents. Thank you.
Thank you so much, sir. It was a very informative lecture. I hope, are there any questions that we have to ask? Okay, it's very clear for all of us. So I hope our participants are well aware about the earthworms and how they are friends to farmers. Thank you so much, sir. I now request Dr. Malik Asif Aziz, Training Coordinator, to present a certificate to Dr. Chesti for delivering an informative lecture.
इसमें समझ आया कुछ कहीं पे कंफ्यूजन तो नहीं है, इजी है ये मेथड.
Sir, is there any replacement for cow dung in vermicomposting?
है ना, हम पोल्ट्री मैन्योर से भी बनाते हैं ना, मैंने बोला ना आपको, बट दैट शुड बी लेस, मतलब दैट शुड बी अमोनिया उसमें नहीं होना चाहिए. अगर उसमें मतलब प्रोपोर्शन उसमें पूरा होना चाहिए, क्योंकि इट कंटेन्स हाई अमाउंट ऑफ नाइट्रोजन ड्यू टू अमोनिया. ड्यू टू दिस आपने देखा एक स्लाइड में मैंने देखा, हम गए कभी फार्मर पे तो वहाँ पे आप देखो अर्थवर्म्स अनईजी फील कर रहे हैं ऑन द सरफेस. व्हाट मे बी द रीजन? दैट मे बी ड्यू टू हाई कंसंट्रेशन ऑफ अमोनिया. जो उसका क्रॉप होता है दैट गेट सोर स्टॉम जो होता है. We can use kitchen waste.
So why do we need
partially decomposed manure? First एक बार मैंने आपको कहा जो fresh manure है, its temperature comes up to 60 degrees. जो हमारा फ्रेश कभी आप जो काव डंग निकलता, मैंने कहा क्यों कहा आपको कि हमारे परसों ही मैं गया ना तापर में, मैं वहाँ पे जो वर्मी कंपोस्ट यूनिट जो बने हैं ना यहाँ सब डिफरेंट है. इवन राजौरी में व्हेन आई हैव जॉइंड, तो रास्ते में जब हम जा रहे थे ना, आपको सड़क के करीब कहीं कहीं पे मोगल रोड पे लगेगा कि वर्मी कंपोस्ट यूनिट बने हुए हैं, बट दे आर अनअटेंडेड. व्हाट मे बी द रीजन? रीजन ये है, when government gives this scheme, for example vermi compost unit I have किसी को देना है, the farmer which is very close to Department of Agriculture उसी को मिलता है. वहाँ पे वो नहीं देखते हैं कि ये फार्मर है ये बनाएगा नहीं बनाएगा. उस बंदे को उनको नहीं पता था कि व्हाट इज वर्मी कंपोस्ट. उन्होंने कहा मुझे मेरे लिए बना, तो उसने जब बनाया तो उसके पास गाय नहीं थी, उसके पास जानवर नहीं था, उसके पास रॉ मटेरियल नहीं था. दैट इज वन रीजन दैट गेट्स, मतलब वो नहीं. सेकेंडली जब वो काव डंग जैसे हमने किसी ने बनाया वर्मी कंपोस्ट यूनिट, उसको ट्रेनिंग भी मिली, जब उसने फर्स्ट फ्रेश ऑर्गेनिक मटेरियल उसमें डाला, तो आफ्टर पहले तो जब हम कहीं पे मटेरियल रखेंगे काव डंग, फॉर फ्यू डेज देयर इज अ लेटेंट हीट, मेसोफिलिक बैक्टीरिया विल वर्क, माइक्रोऑर्गेनिज्म वर्क, बट आफ्टर सम टाइम देयर कम्स अ थर्मोफिलिक स्टेज, द टेम्परेचर ऑफ द मैन्योर कम्स अप टू 60 डिग्री. तो दैट्स व्हाई we use partially decomposed. उस टाइम वो स्टेबलाइज हुआ होता है, तो उस टाइम जो मेसोफिलिक माइक्रो ऑर्गेनिज्म है, those who work between 25 to 35 degree, they work. That is why we should use partially decomposed manure. One of the जो main failure है वर्मी कंपोस्ट का, तो फार्मर का क्या हुआ, उन्होंने वर्मी कंपोस्ट दे दिया, उसने जो बाहर से मैन्योर लाया, we should have to keep it outside for few days, for 1 month. उसने डायरेक्टली उसी में लगाया, उसी में जो वर्म डाला हमने, तो वर्म कितना करेगा. आवर वर्म कहाँ तक टेम्परेचर जो मैंने दिखाया था आइडियल कंडीशन 25 to 35, तो जब 60 आया तो वो वर्म तो डेथ हो जाएगी. वी कैन यूज एनी मटीरियल, इन काव डंग के बगैर भी हम कोई भी मटीरियल यूज कर सकते हैं. इवन पोल्ट्री मैन्योर वी कैन यूज सम, देयर इज समथिंग हॉर्स मैन्योर वो नहीं यूज करते हैं ज़्यादा, बाकी में तो वो यूज.
सर काव डंग में मीथेन होता है,
हाँ,
वो हार्मफुल नहीं होता है.
हम क्या कह रहे हैं, वो हम क्यों पार्शियली डिकम्पोज करते हैं. इवन आफ्टर जो बर्निंग है ना, जो इस टाइम बर्निंग हो रही है, आप गूगल में जाओगे ना, इफ देयर इज 500 मिलियन टन्स जो क्रॉप रेजिड्यू है इस टाइम जो इंडिया का प्रोड्यूस हो रहा है, जो हम फूड लेते हैं वहाँ क्या बचता है रेजिड्यू. आउट ऑफ दैट 142 मिलियन टन्स जो रेजिड्यू है दैट इज सरप्लस. कितना है सरप्लस. उसमें भी 92 जो है वो क्या कर रहे हैं, बर्न. ठीक है ना, जो बर्न हो रहा है उससे क्या आ रहा है, अमोनिया, सल्फेट, कार्बन डाइऑक्साइड इमिट हो रहा है ना, ग्रीन हाउस. लेकिन उससे ज़्यादा हार्मफुल जो है दैट इज मीथेन, जो रूमिनेंट्स है हमारे पास इन इंडिया और अफ्रीका और एशिया में वी हैव हाईएस्ट नंबर ऑफ दीज रूमिनेंट एनिमल्स. तो تو ان میں جو میتھین امیشن ہوتا ہے دے آر دا مین سورس آف میتھین. اس میں جو ہم یوز کرتے ہیں نا وہ یوز پارشلی انڈر ایریٹڈ کنڈیشنز, جبکہ میتھین پروڈیوس ہوتا ہے انڈر سبمرجڈ کنڈیشنز. اس میں کاربن ڈائی آکسائڈ انوالو ہوتا ہے
مارشی ایریاز.
مارشی ایریاز.
سنا آپ نے؟ Is there any other question? دیکھو یہ کوشچن, یہ جو پی پی ٹی چلانا آج یہ تو بیسک تھا. میں
اب آپ کا پریکٹیکل ہم لے گا
تو اس کا ہم پریکٹیکل کریں گے, ٹھیک ہے نا, وہ آپ نو میں کریں.
کیونکہ ایون جو ہم نے لیکچر شروع میں دیکھ رہا تھا نا اس میں نے الابریٹ زیادہ نہیں کیا کسی میں. جیسے کسی کا ورمک واش ہے تو اس پہ تو سر نے فل لیکچر دے دیا.
ورمی واش میں ہم
ایون اکنامکس سے میں نے ایک ہی سلائڈ دیا, لو لیول پہ, ہائی لیول پہ, میڈیم لیول پہ. اس پہ سر نے ایک الگ لیکچر رکھا ہے. ایون بیڈنگ مٹیریل اس پہ تو جو میں دیکھ رہا تھا
سبسٹریٹ مینیپولیشن ہے نا,
سبسٹریٹ چینج ہم کر سکتے ہیں. ایون ہم نے کہا نا آپ کو پولٹری مینور ہے. اب جب کسی کے پاس کچھ نہیں ہوگا then there is a common ratio for farmer. You can say him 1 part of manure use کرو, 1 part of یہ use کرو waste, agri waste. Okay.
Thank you, sir. Sir, this is a small token of thanks from my side.